Good morning, ladies and gentlemen, and welcome to this webinar, which is kind of unique webinar, I would say, as we are talking about a unique product, and we are also having a lot of detailed information for sharing with you. So thanks to the customer who has provided these. We are talking about a flash unit, and this flash, as you can see on the first page, has got a lot of awards, so this is a pretty good development we are talking about. These are the topics of the agenda: the way to the champion, how was the way, and how was the cooperation. Second, the genes of the champion. So what's in the flash? And the third point is what may peak performance cost. We are looking on the cost details of the system. And last but not least, what's left in it. So let's have a closer look to options with the Semiflex technology. So, but first of all, let's have a closer look at the champion, which is called mecablitz M400. It's compact and powerful at the same time. It's a system flash unit, perfectly equipped, attractively packaged. So this is intended to be used with mirrorless system cameras of all the well-known companies you can see on the picture. And for even more details, you can use the link which is provided in the presentation you will get afterwards. So for example, some topics, there is an USB interface to make new firmware on the system. For example, there's a flip-out reflector card integrated. There's a really bright LED video light integrated in this. So just some of the technical features. So the way to the champion, in the beginning there was of course a target, and the target was the leading fair Photokina, which was dated in September. And the point of contact was in February of the year. So the customer found some useful information on our website and thus contacted us for technical support in their project. So we talked about different possibilities of stack up for the system, and then the next big milestone for us in the cooperation was in April, where we had a technical meeting at the company Metz with an, I can only say it was a super team. All the disciplines were there, which are important, beginning from purchasing department, ending in production, specialists and quality management, designers, all the people were there. We need to find a very fast and brilliant solution for the requirements. And then February, April, the next milestone in the cooperation was August. And so this is a really short time frame. In August, the start of the series production took place. In the beginning, there was a briefing about the specifications, and one very important point was the system has to be as small as possible. Another thing was the energy providing for batteries you can buy everywhere. And this was at the same time the limit for the miniaturization. So we had to think about possibilities to have a lot of electronic functionality in a very limited space. So at most, it is in tasks for miniaturization, you have even more features and more functionality, but less space for that. There was a requirement, a high guide number. So the guys who like to make pictures and good pictures, at least, they know about guide number 40 for a very small flash. Next thing was, it should be a perfect all-rounder for mirrorless system cameras, as I already mentioned. And last but not least, as cheap as possible. So we have been limited in the choice of the possible PCB technologies. So flex rigid would have been nice, but as you know, flex rigid is not that cheap. It's not that cost effective in sometimes. So we had to think about Semiflex. The perfect thing was that we had these contact and this meeting in a very earlier phase of the project. So looking at the design chain, we've been somehow around the specification status. So that was really helpful in the project. So this is the outcome of the project. You can see the M400 on the left side, and compared to an older flash unit, you can see there was a remarkable shrinkage, and even with more capability in the system. Here we can see two pictures. The left top one is the M400, and we can see there are not a lot of cables and connectors in the system. It's quite unique, homogeneous 3D design. And on the right top picture, you can see an older flash unit I had from older days, and I just scrapped that, and to make the picture you can see a lot of separate PCBs combined with cables, connectors. So that's quite a huge difference, even if we think about assembly and reliability and cost, last but not least. So what are the genes of the champion? The heart of the champion, let's say, is a Semiflex printed circuit board with 4 copper layers. So we call that 1RI, 3RI. That means in the rigid area we have 4 layers. In the bendable area there is 1 copper layer. This is the flat projection of the PCB, and this is the final assembly situation in the flash unit. So these are 2 pictures from the real unit, and we can see the battery unit, and we can see the banded Semiflex PCB directly around this battery case. It's even better to see that in this transparent mode of the system of the picture we can see here. So again, there's the food, and there's a battery case, and the Semiflex just, let's say, wrapped around the unit. So it's really perfect miniaturization. Let's have a closer look to the stack up. As already mentioned, we have 4 copper layers in the rigid area, and in the Semiflex area there is just 1 copper layer. So it was part of the discussion in April whether we can meet the requirements with just one copper layer, and finally we decided not to go with 2 copper layers in the bendable area, but to use smaller copper lines, so to get all the connections. So finally that was the cheaper way, and this always good to have this early communication about different possibilities of solutions. I want to remember that Semiflex does not have flex areas but bending areas, as we don't have a flexible material like polyimide. It's just a thin, rigid material. This has an advantage that prior to the assembly and soldering process, we don't need a separate drying process. The Semiflex technology is qualified for minimum 10 bending cycles, but of course the bending radius is larger compared to a flex rigid technology. So we have to care for the bending radius, and as well we have to care for the direction of the bending. So this is shown in the picture now shown. There's also the formula how to calculate the necessary length L in the flat projection to get a minimum bending radius R. So also the bending direction, you can see here, the bending has to be performed that way that the milling area, the reduction area is inside the bending and the copper is outside. To make it a little bit easier, we have calculated the most common angles for radius 4 mm, respectively 5 mm. So 4 mm minimum bending radius is possible with the shown stack up with a multi-layer stack up. It's important to care for the material constructions, as you can see here, 4 different types of prepreg constructions, and the single glass fibers are really different in diameter and as well in rigidness. So we have to find a perfect compromise for the bending, which is not too fine, but at least not too coarse as we have it with the 7628 prepreg, for example. So it's also important to have a look at the base material and the resin and maybe fillers inside. So still today the standard FR4 is the best for bending. So TG 135 shows the best bending properties. But it's also possible to use mid-TG or even high-TG materials with fillers, but generally they worsen the bending properties. Let me show you some more design rules and tips for Semiflex. It's really important to have a balanced copper design in the bending area. So if there are copper-free areas, please fill that with conductors or with the crosshatch to get evenly distributed bending resistance in the bending area. That helps a lot for a reliable and repeating bendability. So it's good also to have big contour radii, which also supports the bending. The design rules you can get on our website, by the way. Another situation is this you can see here with 2 rigid PCBs with a relatively large distance in between and a bending with 180 degree. So we strongly recommend to change the 1 times 180 degree bending to a 2 times 90 degree bending. That's more controllable in the bending, and Also, it's not that space consuming. And finally, you can use the rigid intermediate part for design, routing, for components maybe. So here you can see just one example. Next thing is that we have to regard the bending direction, as already mentioned. So it's not possible to have a to have a semi-flex area with an S-shape bending. So we have to do it like it is shown here with a special construction, semi-flex areas on different sides, and thus it's possible to make an S bending like we can see in the picture here. Another thing, for a high reliability, we recommend, for at least for some special applications, the use of a bending aid, as we can see on the left picture. So sometimes it's really helpful to make a pre-bending prior to the final assembly into the box. Another possibility is to integrate some radii, like a bending aid, into the housing of the system, as we can see on the other two pictures. So then we don't need a special pre-bending. Last but not least, I want to point out that we have also to care for the array design, the delivery array, and as well for the panel separation possibilities. So semi-flex area must not be damaged during separation. So please take care for a really good array design. We like to assist you in this. Now this is a really exciting example. A tube and a semi-flex printed circuit board with heavy connectors you can see here. So the question is, how do you get this complex semi-flex in the box without damaging that and without damaging your hand maybe? So there's quite a nice tool which is used for that, and it's part of the construction of the design to also design these tools for perfect handling. And the perfect handling looks like this. First of all, the first connector is fixed to the bending tool, and then the flex is folded around the tool, and another fixing of the second connector. So now the PCB is pretty good fixed to the assembly tool, and the system could be assembled. Fixing of the connectors, first connector, second connector, and then the assembly, bending and assembly tool could be twisted out. So that's quite an interesting thing. Another idea is the combination of a bending and fixing tool in the box construction. So you can see the two radii at the corners, and this is a semi-flex PCB. So first of all, one of the rigid parts is fixed to the system, the red system, and then afterwards you can just bend the other two rigid parts down and finally fix it by a screw. So that's a perfect situation also for shock and vibration in the system, so that there is a high reliability in the system. So does that look familiar to you regarding the flash? So now we're coming back to the flash unit, and it's more or less exactly the same the guys at Metz Mecatech did with their design. So this is the flat projection of the semi-flex PCB, and this is the battery case appearing. And the first step is to fix the battery case to the middle part, rigid part of the PCB. And then next step is to perform the bending. So now it's just wrapped around the battery case. And there's not big need for a lot of space, so it's really miniaturized. Next step is the first part of the case appearing. Then that looks like this. Next step in the assembly process is the other half of the housing. Now assembled. So now you can see the relationship of the volume of the battery case compared to the complete volume of the system. So that's quite impressive, I think. Now the flush top is assembled, and then the battery case is opened and the batteries are coming, flying into the box. Closing the door. So the flash unit is ready to work. And yeah, perfect job, guys, at Metz. I think that's quite a unique product and design. Semiflex technology, regarding the market, we can state that the technology is well proven since round about a decade, and the markets are, for example, automotive market, for cameras since long time, control units, actually some projects caring for new generations of headlights, where you need quite a lot of electronic in the headlights, transmission electronics, or industrial market sensors, LED lights, drive technology, hydraulic control, heavy mechanical engineering, security technology, or building services engineering. So actually in one country, the north of Europe, we have high volumes of Semiflex PCBs used in smart water metering. So, for example, or access control. So Semiflex is well proven and widely used. Medical technology, charger, handheld devices, for example, or even railway technology for a ECU of a diesel engine, and last but not least for geotechnics, the switch box we cared for in one of the webinars. You can see on the right bottom side. So next point, what may peak performance cost? And again, this is the box I told about. We made a webinar in 2015. You can find that in our webinar archive in all the details. I just want to pick out the cost aspect of this system, and it's quite good comparable to the flash unit, as it's the same stack up. It's also a 4-layer with one copper layer in the bending area, so a 1 RI, 3 RI, as we call that. And for that system switch box, we made a total system cost comparison. On the left side, you can see the modular system with separate PCBs with cables and connectors, and on the right side you can see the homogeneous semi-flexible PCB. So we cared for the prices of the PCBs for 100 pieces and 1,000 pieces, also to see the volume impact. And then costs for cables, connectors, assembly, test and final assembly. And finally, we found for the bill of material and the processing quite a huge difference and a big advantage for the Semiflex PCB. But that's not all. To be honest, we have also to care for the complete system, and there are some even more things to consider. For example, for the modular approach, we need design for 5 PCBs. We only need 1 for the Semiflex job. We have a lot of even more expenditures for assembly, for inventory control, for tests, for stocks, 22 positions for the system compared to 3 positions on the Semiflex part. And last but not least, concerning reliability, it's a really big advantage to get rid of 312 contacts and 312 solder joints if you use a Semiflex solution. So that's quite a good argument in terms of reliability, improvement in reliability for the Semiflex approach. So let's come to the final point, what's left in it. Let's have a look at the roadmap or some options we can also provide. So Semiflex constructions for special requirements. For example, we can cover the banding area not with flexible solder mask, which is our standard, but we can also use, for example, coverlay, which is made out of polyimide, which is more robust and even more stable. So that could be an advantage for some systems and applications. We also can use improved base material with a mid or even a high TG resin, for example, TG 150 or even more, which may be an option for special requirements. Another thing is the usage of 2 copper layers in the bending area. I will come to that point later once more. And we can also use an adapted laminating technology resulting in an improved bending behavior. Also for thicker bending area, so 2 or maybe even 3 copper layers in the bending area, and also applying a smaller bending radius. And last but not least, we also have the possibility to make a combination with HDI technology, so applying micro wires, buried wires to the stack up, and thus providing HDI capabilities. So 2RI, XRI, this is our terminology nomenclature for the Semiflex stack up with 2 copper layers in the bendable area. And one application could be if you have a very high number of connections over the bending area. Using this approach with an additional rigid part and a Semiflex area in between to make a 90-degree situation saves a lot of area on the main board. So that could bring down costs and also helping for miniaturization. The other thing is to have a complete reference layer in the bending area for impedance matching. So if you have high data rates, for example, or high frequencies. So replacement of high pin count connectors and shielded cables, bringing down costs and improving capability. And in this case, the price advantage is even higher, as shown with the box. If you have two copper layers in the bending area, there are different approaches how to do that in the stack up. We have also to care, for example, for the construction of the cores, if there is a core in the bending area, or to make multiple lamination processes. So that's what we have to discuss for each project and then find the best situation for the requirements you have. So just to show two examples on the left side, this is prior to the optimization. You can see the bending area quite rough. You can bend this for sure, but it's not that good, as you can see on the right side after the optimization, with a very smooth surface and quite a perfect bendability. So let's come to the summary of today's webinar. So there's one thing I just have to do. I have to say congratulations and as well many thanks to Metz Mecatech for the really good cooperation and also for the information we could share with you. Thanks, guys. So Semiflex finally is an affordable 3D technology for reliable miniaturization solutions. And last point, Semiflex solutions are always project specific, so we will be happy to advise you. You can find more information in our webinar archive, as well for flex rigid or for reliability issues or for Semiflex technology. And one last note, there is a congress beginning next year in January in Munich, Altium Live, and I will be there and make a presentation about digital standards for EDA tools. So thank you very much for your attention and participation. Have a good time, and I give back to my colleague. Thank you. Bye.